So yesterday we started on solving quadratic functions. Today we're going to do a couple of more methods, just one extra method today. Yesterday we talked about graphing, which we used our calculator for, and then we also talked about the quadratic formula, which we had an awesome song to. So the next method is by factoring, but you've been doing factoring for quite some time. So, and remember, we like to use blankety blank in my classroom. Now, whenever we're factoring, there's only one additional step we have to do at the end to find out what the zeros or our solutions or our roots are for our quadratic functions. So, let's start with example 1. We're going to solve by factoring. Now remember, these are quadratics, so the highest exponent is x squared, and we're going to have some great examples coming up. Okay, the first example, we have x squared minus 6x plus 9 is equal to 0. So we're going to go ahead and set up our blanks. Remember, we had blank times blank is equal to a times c. And remember, a was what is in front of x squared, so we got 1 here. So we got 1 times 9. Then we have blank plus blank is equal to b. And b is in front of our plain x, so we have negative 6. Oops. Okay, so then here comes the hard part. This is where we got to think to ourselves, what is going to multiply to a positive 9 but add to a negative 6? Well, first of all, we know since we're adding to a negative, that both of our two terms, our numbers, have to be negative. Because, also, look here, whenever we're multiplying, we get a positive. Remember, a negative times a negative is a positive. So, after we think about it, we get negative 3 and negative 3. Remember, if it goes in the first set of blanks, it's also got to go in the second set of blanks. Then, the next thing we do is we take what's in our blank, which is negative 3, and we put it over a, which is 1, in our variable, which is x. Now, technically, this can't be reduced, but a lot of you guys like to rewrite it as negative 3 over x, which is great, and that's one of our terms. Now, if you haven't noticed from all the factoring we've been doing, if I did the same thing to the second blank, I would end up with the same exact thing. So I'm just going to stop here and know that I've got to write it twice. But in case you wanted to, there's the other term. So remember, when we write them, we write denominator, numerator, denominator, numerator. So our two terms are x minus 3 and x minus 3. So here's where things start changing. We have been stopping here and saying, boom, it is factored, we're done. So now, what we're going to do is we're going to take both of our two binomials, we're going to come up here, because I'm running out of room, and we're going to write x minus 3 and x minus 3. We're just going to rewrite it. Now, in order for this quadratic function to be equal to 0, we need one of them to be equal to 0. So we're going to go ahead and use our 0 property. We're going to set up x minus 3 is equal to 0, which is that one. Then we're going to do the same thing for the other one, which happens to be the same thing in this particular example. Then we're going to solve both of these. If we add 3 to both sides, we get x is 3, and the same thing for over here. So here are our solutions, but remember, we only got one solution, so we can just write that x is 3. So technically, our quadratic function only comes down and just touches our x-axis. All right, let's do another example. Let's look at this one. We have 4x squared minus 10x minus 3 is equal to 0. Actually, I wrote the wrong thing. 4x squared minus 10x minus 6 is equal to 0. Sorry, kids. All right, so we have our trinomial here. We have our quadratic function. We want to factor it. Now, the first thing you're always supposed to check is, do we have a GCF? So we need to look and see, do we have a GCF? And actually in this case we do. All three numbers are divisible by 2. So we're going to pull a 2 out. 4 divided by 2 is 2. 10 divided by 2 is 5. And 6 divided by 2 is 3. So now we can go in here and we can do blankety blank. So let's set up our blanks. We have blank times blank is equal to A times C, so 2 times a negative 3, which is negative 6. And then blank plus blank is equal to B, and B in this case is negative 5. So here's where we got to think. We're adding to a negative, but we're also multiplying to a negative, so we need one term to be negative and one term to be positive. So after we think about it, let's see. We can fill out negative 6 and positive 1. Remember, if you put it in the first blanks, you got to put it in the second blanks. Now, next step, take what's in our blank. We'll put it over A, and we're going back to the 2x squared version of it. So we have 2 in our variable, and that actually can be reduced. Both of those are divisible by 2. So we have negative 3 over x. That's one of our terms. And then for the other one, we have 1 over 2x. That cannot be reduced, so that's our other term. So let's go ahead and write these terms. Remember, we do denominator, numerator. So the first one is x minus 3, and the next one is 2x plus 1. But we cannot forget, what did we take out at the beginning? We took out a 2. So here's our factored quadratic function. Now, here's the next thing we got to do. I'm going to come up here to the top. I'm going to rewrite it. X minus 3, and then 2x plus 1. And we're going to set that equal to 0. Now, technically, we have 3 things being multiplied here. We have 2, x minus 3, and 2x plus 1. We've got to set all 3 pieces equal to 0. But when you set 2 is equal to 0, does that make any sense? Nah. We're going to kind of throw that one away. Actually, what that 2 does is it really just changes how skinny or how fat our quadratic function is. So we really need to focus on the x minus 3 equal to 0 and the 2x plus 1 equals 0. So for the first one, if we add 3 to both sides, we get x is equal to 3. And that's one of our solutions. For this next one, we need to subtract 1 over first, and then we need to divide by 2. So x is a negative 1/2. So our two solutions, 3 and negative 1/2. Okay, let's do another example. We're going to do x squared minus 6x is equal to 0. Now, in the previous 2 examples, we had 3 terms, and we went ahead and did try to find a GCF, and then try to do the blankety blank. So remember, when we're factoring, number 1, we want to try to figure out if there's a GCF. So if you take a look at these 2 terms, they actually have an x in common, so we can pull out an x. So we're going to have x, and then x squared divided by x is x, and negative 6x divided by x is negative 6. Now, there's nothing left for us to factor here. We can check this by redistributing our x, and we'll come back up with x squared minus 6x. So now, this one's pretty easy. We've got to set this piece and this piece both equal to 0. So for the first one, we have x is equal to 0, and for the second one, we have x minus 6 is equal to 0. There's no solving to be done on the left one, but on the other one, we can add 6 to both sides, and we'll get x is 6. So our two solutions are 0 and 6. Okay, let's do another one. We're getting good at these. We have x squared minus 36 is equal to 0. Always check for a GCF. If we look at these 2 terms, they don't have a greatest common factor. Then, remember, if we have 2 terms, we want to check for some special cases. We want to see if there's a difference of squares, a sum of cubes or a difference of cubes. Now, if we take a look at our two terms, if we have a sum or a difference of cubes, we obviously have to have something cubed in there. We don't have anything cubed. So what we have here is a difference of squares. The square root of x squared is just x, and the square root of 36 is what? 6. Now that we know what the square root of both of our terms are, remember, we write our first term plus our second term, and our first one minus our second one. And this hasn't changed. We're setting them both equal to 0. So here's where we do our new stuff. We got to take both of these and set them equal to 0 and solve. So we have x plus 6 is equal to 0, and x minus 6 is equal to 0. When we solve the one on the left, we get x is negative 6, and the one on the right, we get x is 6. So our two solutions are negative 6 and positive 6. Let's do two more. So the first one we're going to do is, let's do this one, e. We have x squared plus 2x plus 5 is equal to 0. You always want to check for a GCF, and these terms don't have any common factors, so we don't have a GCF, so let's go ahead and let's try blankety blank. So we have blank times blank is equal to a times c. A in this case is 1. So 1 times 5, which is 5. Then we have blank plus blank is equal to b. And b in this case is 2. So here's where we start running into some problems. No matter what factors 1 and 5 or 5 and 1 we put in our blanks, none of those are going to add to positive 2. So we're going, what's going on here? So we actually have something that's prime. It can't be factored. But luckily, we learned yesterday that we can use our wonderful calculator to figure out what's going on. So if you want to put this in your y equals and graph it, let's take a look at it. Let's see if it touches the x-axis. If it doesn't touch the x-axis, we don't have any real solutions. So actually, when you put this in your graphing calculator and take a look at it, it doesn't even touch the x-axis. And also, if you use the application, it'll tell you that there are no real solutions. So the answer to this one is no real solutions. So let's do one more, last one of the day. We have x squared minus 6x plus 6 is equal to 0. Let's check. Is there a GCF for this one? Absolutely not. There's no term that is common. So let's try blankety blank again. Blank times blank is equal to a times c. So we have 1 times 6, which is equal to 6. Then blank plus blank is equal to b, which is negative 6. So let's think about this. Do we have any two terms that will multiply to a positive 6 but add to a negative 6? So keep in mind, if we're multiplying to a positive but we're adding to a negative, that both of our terms need to be negative. Running through the list of factors for 6, we don't have anything that fits in there. So this is kind of similar to what we just did. We don't know. We don't have a clue. Nothing works. So again, we need to go on the calculator and take a look at it. Actually, when you graph this one, it crosses the x-axis twice, but we can't factor. It is actually prime, but in this case, we actually have some solutions. So either you can use second calc, go to 0, and get our solutions, or you can use the application. And when you find the solutions, you actually get 1.268, we're rounding a little bit, and 4.732. Now, just because a quadratic function is prime does not necessarily mean that there's no real solutions.